Although the Amiga was originally conceived as a gaming machine, Commodore had always emphasized the Amiga's potential for professional applications. But the Amiga's high-performance sound and graphics were irrelevant for most of the day's MS-DOS-based business requirements, and the machine could not successfully compete with PCs. In 1984, Commodore introduced a range of PC-compatible systems, and sold them alongside the Amiga, the C64 and 128. This miniseries is about this 1988 Commodore PC-10. I picked it up years ago and it turned out to have the worst battery damaged board I have ever seen. In previous videos we have removed all damaged components after having to grind away a layer of corroded solder for the flux to have an effect. With some of the components out of the way, we managed to clean and remove the corrosion on all damaged traces. Then we moved on and tinned all the exposed traces and bodged all breaks we could find with thin wire and copper tape. We also found a burned trace near the graphics chip, and this is likely what put this Commodore out of service. Since then we have replaced all damaged components with new parts from well-known suppliers and new old stock parts of eBay. We left off the project 2 weeks ago by trying to boot the system, but we got a black screen. The scope indicates that the CPU is running normally. We have also checked for shorts on the power rails, and we have checked the voltages. We ended the video by testing the board with an external graphics card, and we did a blind test with a disk in the floppy drive. So the board is running somewhat, but it does not complete post or display any graphics. The diagnostic card isn't of much help with this board, unfortunately. However, a viewer made a couple of diagnostic ROMs for us to try out, so thanks Greg. Okay, so these are 27C256s. And let's start with this one, and it's just called Beep ROM, and it will only write a few post codes, and then beep forever. It doesn't require any memory, so we only need a working speaker, a running CPU, and a working ISA bus. And I have already blank checked the EEPROM, and I found a couple of ROMs in my stash from National Semiconductor, but they are nowhere to be found in the software. So I'm gonna try with AMD 27C256. Okay, programming succeeded and verified. So let's try it out on the board. But first I'd like to thank PCBWay for supporting today's video. Aside from making excellent PCBs, they also do CNC machining, sheet metal fabrication, 3D printing and injection molding. Perfect for makers like us. Get an instant quote now at PCBWay.com. Thank you PCBWay for supporting this channel. Okay, some deoxit magic in the socket first. This is the original socket, but it's a dual wipe socket, so I didn't bother to replace it. And I hope that's not a mistake. And our freshly made EEPROM. So let's see if it beeps. Well, we know the CPU is running. Hey, it's working! Okay, so that implies that we have an at least partially working ISA bus. And as we saw on the scope, the CPU seems to be running. And obviously a working speaker. Well, in that case, I guess we'll try the next ROM. Okay, so next up we have Post ROM. This is the normal FE2010A build of GLA BIOS, but with debugging postcodes enabled. And I have blank checked the EEPROM, but we still got a fail. Now it's not blank anymore, so let me see if I can find another EEPROM. Okay, freshly erased EEPROM in the TL866. Let's try again. And this time it worked, so let's try this EEPROM out. Okay, EEPROM number 2, let's see what it does. We get postcodes. So I guess I need to check what they are. Before we move on, let's try the third ROM. And it gets stuck too. So I need to check what those codes are. Okay, so I just got an email from Greg. These beep codes are for base RAM error. So let's move to the workbench and see what's going on. Okay, so I went through the tedious task to check all the traces for breaks and shorts. Check this out. So this is address line 1. This chip here is not connected. So we have a broken trace. Let's see if we can find that break. So this socket here is connected to this trace here. But from this chip here, there is no connection. So the break seems to be underneath the socket here. Let's pull that chip and take a look underneath. Oh yeah, it's connected here. But on this side, nothing. So we have a break underneath this socket. So let's take it out and see what's wrong. And by the way, I think I have saved up for a microscope camera now. And I was planning to buy that Eakins camera that Dave Jones made a review of. But then I realized that review is 4 years old. So please feel free to leave your recommendations. Is that Eakins camera still the best choice? Or is there something new I should consider? So let's see what's going on underneath that socket. Okay, so I can see one repair here with copper tape. That's for another pin. That one is still good. So this is address line 1. And yeah, sure enough, there's a break here. That is one tiny break. I'll see if I can make it close up. Well, there's definitely a break here. And it's so small, it's invisible to the eye for sure. Well, that is one tiny bloody break. Even under extreme magnification, I can't really see it. It's just a really thin crack. Let's try to just bridge it with solder. This is why I need a microscope camera. This is almost impossible to get on camera. Well, I can't see the break, but I know it's here. So let's just add a large solder blob and see if that is enough. No, it's not. So we're gonna have to use a bodge wire because it's very close to these legs. And I think if we repair it with copper tape, it will probably melt when we solder in the socket. So let's repair it on the other side of the board. So let's clean this mess up and add a fresh socket. Yeah, I never had a break before. So small that I can't even see it under extreme magnification. I wonder how much magnification it would actually take to see that crack. So let's do this one with enamel wire. Let's clean this mess up. So let's just quickly check for continuity. Yep. So I'll just put those chips back on the board and we'll make a new test. Okay, let's see if that made any difference. And it beeps the same error code, so no difference. Crap, so let's just keep looking. Well, I managed to find an expansion board that uses the same RAM chips as this Commodore. But unfortunately it tested good. And we still have the same problem with the motherboard. Well, at least now we know that the RAM chips are good. Well, if the RAM chips are good, I guess it's something else. And we might as well start with the easiest components. Well, I don't have a CPU quite this fast, but I do have a regular 8088. Let's see if it makes any difference. This CPU is freshly tested. Let's flip the switch and see what it does. No difference whatsoever. We might as well do a quick test with the CPU from the Commodore. And it seems to be working. Yeah, that Siemens chip is good. Let's see what kind of activity we have on those RAM chips. So address line 8 looks perfectly normal. Data in, nothing. Write, nothing. So A0 looks normal. A2, A1, and D out, nothing. A6, A3, A4, 5, and 7. Well, the TL866 can test logic chips, so that's what I think I'm gonna try now. Yeah, I've never tried this feature, so this could be interesting. And we have a bunch of logic in this area. So let's see what we've got. 74S00. So the lowest numbered logic in the 74 series. Okay, let's see how this works. So under devices here we have logic IC test. Let's search for 74S00. Not found, so let's skip that S. 7400 and test. All vector testing normal. Okay, so I don't know how good it is. Perhaps we should try the original chips and see what results we'll get. Okay, so this is the original 7400 that was on this board, and it was extremely corroded, but I have cleaned it up as much as possible. Let's see how it tests. And it's testing good. So I don't know how good this tester is, but this one seems okay. So let's see what we've got next. 74S10. All vector testing normal. So that one seems good too. Although that socket is a bit suspicious. Yeah, I'm gonna have to check this. And here's the original chip. And it's really crusty. But it's testing good. So let's test another one. Yeah, this socket here is suspicious for sure. It looks really weird. This one is a 74S04 and it's testing good. And here's the original chip. Test failed. So here's one of the reasons this Commodore didn't work. Next up we have a 74LS158 and it's testing good. And here's the original chip. They are really crusty, but it's still good. And then we have another 158 and it's testing good as well. And here's the original chip and it's still good. And there's actually a third 158 down here and it's good. And then we have the original chip and it's still good too. And then we've got a 74LS245 and it's good. And here's the original LS245 and it's still good too. And then we've got an LS08 up here. But that one is probably not involved with the RAM. Let's try it out anyways. And it's good too. And the original chip failed. So 2 of the original logic chips were bad. But the rest is still good. And I'm not surprised. Okay, so all the logic chips are good. But I really need to check this socket here, because it looks really weird. So I guess that's the next thing to try. So here's that weird socket. So when I push on the chip, it goes down, but then it comes right up again. So it may not make good contact, so let's replace it. And this socket is new, but there's definitely something wrong with it. So let's try with the new. Well, I guess the next thing I have to do is to make a proper visual inspection in case there are more stupid faults like this bad socket. Okay, let's test that socket. And still the same error codes. And I went back chasing traces. And I found something really weird. So check this out. This trace here is seemingly good. But check this out. That should have 0 ohms. But the resistance just keeps climbing. Let me turn that beeper off. Yeah, it starts off at 10 ohms. And it just keeps climbing. So what's up with this? And it seems to stop at 12 ohms. That is a rather weird behavior for a trace. So let's take a look at it and see what's going on. So here's our trace. And if we measure on the trace itself, we've got 0 ohms. And if we measure on this side of the socket, we've got 30 ohms, 55, and it's climbing to around 100 ohms. So something really fishy is going on underneath this socket here. So let's pull that socket and find out what's underneath. So I had a look underneath and I thought it was this bodge, but it's not. It's actually this trace here. So let me quickly pull that socket off. Okay, sockets are gone. Let's see what we've got underneath. And we're still getting 5 ohms. So somehow this trace here is introducing some resistance. I guess it's too thin. Not sure really. So the obvious thing here is to just reinforce it with a bodge wire. So let's try that. Okay, so this one is good now. But I continue to check the traces. And check this out. This one is behaving in the same weird way. It would have been interesting to take a look at it under a proper microscope. And at some place it's probably very, very thin. So I'll add a bodge wire to this trace as well. Okay, another bodge added. So this trace is good now. I think it's time for a test. Okay, let's see how it behaves. No, still the same fault code. So I'll keep checking those traces. And I found another break, so address line 5 doesn't reach these two chips. So if we check the traces below, we've got contact here and on this trace here. The trace is probably too thin underneath the socket here. So I'll add another bodge wire. Okay. One more trace fixed. Let's see if it made a difference. No, still the same bloody error code. I guess I'll keep checking traces. And I found another invisible break here, so let's try again. Nope, still something wrong. I guess I'll keep looking. Okay, so I went through all the traces in the entire RAM area. And I fixed quite a few broken traces. So I'm pretty confident that all the traces, at least in the RAM area, are now good. So let's take a look at one of the 41256s and see what's going on this board. So address line 8, D in and write. And RAS and address line 0 and address line 2 address line 1 CAS D out address line 6 address line 3 address line 4 address line 5 and finally address line 7. So at least it's trying to do something, but it's pretty messed up. So I'm running out of ideas here, and I'm also running out of time for this week. Well, some progress this week with the messed up Commodore PC-10 board. It's executing code and has passed a few steps toward the proper post, but we're not quite there yet. I'm kind of stuck at this point, so suggestions are more than welcome. And a special thanks to Greg for helping me out with the Diagnostic ROMs. And I will of course get back to this project as soon as I have a small list of things to try out. Thank you for watching. If you want to support this channel, like, subscribe and leave a comment. Don't forget to ring the bell below, and I'll start recording the next video.